I am John Samuel, Assistant Professor of Physics, Bishop Heber College.
We have a revision on Hooke's law. Already we know what Hooke's law is. The law says within elastic limit, the stress is directly proportional to strain. Within elastic limits, stress is directly proportional to strain. So wherever there is a proportionality, we should have a constant. So we may write stress by strain equal to constant. That constant is known as constant of elasticity. It has a unit Newton per meter square. It has dimension m, l power minus 1, t power minus 2. So unit and dimensions are given here. And we have three kind of model of elasticity. First one is Young's modulus. The symbol is capital E. Young's modulus is the ratio of longitudinal stress to longitudinal strain. Longi means lengthwise. Lengthwise stress to lengthwise strain. So we know stress is equal to restoring force by unit area. So the symbol is F by A. What is the meaning of strain? Change in length by original length. So change in length is noticed as small l by capital L. How can we identify change in length? New length minus original length. How can we get the new length? For example, take this one. For example, this has 4 cm in length. Now I apply stress. It becomes 6 cm. So 4 cm became 6 cm. So what's the new length? 6 cm is the new length. What's the original length? 4 cm is the original length. So what is the strain? 6 cm minus 4 cm is the length, change in length. So 2 cm is the change in length, 4 cm is the actual length. The ratio is 2 by 4. It has no unit because centimeter and centimeter will get cancelled. So the strain does not have any unit. Strain has no unit. So E is known as F by A by L by L. So we get F dot capital L by A dot small l. So E can be written as F dot original length by A into change in length. So this is the unit, this is the Young's modulus. This also has the unit Newton per meter square. All the moduli have the unit Newton per meter square because strain does not have any unit. Only stress has the unit. So we have the unit as Newton per meter square. Next one is rigidity modulus. Rigidity modulus. This is known as G. The symbol is G is equal to tangential stress by shearing strain. What's the meaning of tangential? Let us take this one. I have this material. So now I apply change in angle. I am just shearing, turning this one, rotating this one. Even if I apply rotating force and I release, this come to original position. Even if I enlarge and give rotation, this will come to original position. So this is, we are changing angle, angular stress, rotational stress, that is known as tangential stress. The change in angle is known as phi. Phi is given in radian. So change in tangential stress by shearing strain F by A by phi. Phi is the change in angle. So this is rigidity modulus. Bulk modulus. Bulk modulus, the symbol is K, capital K. K is equal to bulk stress by volume strain. Bulk stress is known as pressure P. Change in volume minus V by V. Why do we give minus V? I compress this one. I press in all the faces. All the sides are compressed. Volume will increase or decrease? Slowly volume will decrease. Whenever we compress, the volume will decrease. The volume will get decreased. So we are using negative symbol. New volume minus original volume. New volume will be smaller than the original volume. So we get the negative symbol. Okay. So bulk modulus is the P by minus V by V. P stands for pressure, V because we apply pressure in all the directions. So volume is decreased. So we use negative symbol minus V by V. So far we have studied three models. What are they? Young's modulus, rigidity modulus and bulk modulus. Young's modulus related to length. Rigidity modulus related to angle. Bulk modulus related to volume. So all the moduli have the unit Newton per meter square. Then we shall study Poisson's ratio. Okay. You may have noticed this one. I apply stress to this one. Here the length is increased. Length is increased. Length is increased. But did you notice that the width is decreased? Yes. The width is decreased. See, look at the width. This is the width. Whenever I apply stress, as long as the length increases, the width also decreases. So we have two changes. Length increased and the width decreased. So ratio of these two is known as Poisson's ratio. Here we have, this is the original size of the material. Now we apply stress in both the sides. So length is increased. As the length is increased, the width is decreased. The width is decreased. So Poisson's ratio is the ratio of lateral contraction to the longitudinal elongation. Contraction, the length is decreased, the width is decreased. This is known as contraction. This is elongation. The length is increased, the elongation. So Poisson's ratio is the ratio of lateral contraction to the longitudinal elongation. The symbol is mu is equal to mu by lambda. Contraction is noticed as mu. Elongation is symbolized as lambda. So nu, this is not V, nu is equal to mu by lambda. Nu is equal to mu by lambda. Poisson's ratio does not have any unit because both are in centimeter. Centimeter will get cancelled. So we have no unit for Poisson.